In the previous module we looked at access points, maps and mesh, but there's one other setting that relates to the access points, and this is services. Now services has a lot of information in there, and it's best to think of it in terms of the services that affect directly the performance of the radios, and some of the services the access point will perform that aren't really directly related to the performance of the radios, but are channeled through the radios. So we'll cover this in two parts, and in this part one I'll be looking at the settings that directly relate to how the radios perform. Here we are then under Configure Services. Services is all the way down here on the left, and we'll begin by looking at these first two options, Self-Healing and Background Scanning. The first option we see under Self-Healing is automatically adjust AP radio power to optimize coverage when interference is present. What this means is that the zone director will automatically change the power on the access point when it detects interference. And interference in this case is when one of our managed access points detects the transmission of another access point that's managed by this zone director in the nearby vicinity. For this to work, the access points need to be set to auto. That's the power setting needs to be set to auto in the access point configuration. The access points need to be able to hear each other, so that means that the access points are picking up other access points that are managed by the same zone director, and they need to be able to hear each other with a certain signal strength, and the difference is 50 dB, which means that the access points need to be very close to each other for this to kick in. In general, Ruckus doesn't recommend enabling this feature because it can lead to some performance problems with the access points. Don't forget, we can dynamically scale back the power according to the data rates that we're using and by the effective use of the beamflex antenna array. So it's best to run the access points at full power to maximize the throughput and signal to noise ratio levels and maximize the data rates and performance. The general rule is to let the access points work out the power settings for themselves. The next setting we'll see is whether to automatically adjust the 2.4 gig and 5 gig channels using background scanning. We can see in the lower section that background scanning needs to be enabled, and it will run every 60 seconds. So what is background scanning? Well, background scanning is when the access point operates on a certain channel and then periodically will leave that channel, go to another channel, scan that channel, and then return to the original operating channel. And then 60 seconds later it will move to a different channel, scan, and then come back. And what's it looking for when it scans on those other channels? It's looking for other access points. We can use that data to automatically adjust the channel. What it means is if we have to move channel, so if we detect interference we have to move from the channel that we're on, we already know information about the channels that we can move to, and therefore it makes that jumping decision a bit easier because we know the profile of the channel that we're going to jump to. We do have an alternative, and that is to use something called channel fly. There are plenty of videos online that will go into deep detail on how channel fly works, and I do recommend that you do go back and look through some of those videos. So here's a quick overview as to how channel fly works. Channel fly will begin with the access point operating on a set channel. After a period of time, the access point will send a channel switch announcement by announcing in the beacon that the access point is about to change channel. It will then move to the new channel and then continue to operate as normal. The clients that are able to read the channel switch announcement will just follow on to the next channel. Those that aren't will just lose contact with the access points and will roam onto the next channel naturally. So it doesn't really impact network operations. Now, once the access point has settled on that channel for a while, it again sends out a channel switch announcement and moves up to another channel. Over a period of time, the access point will be able to scroll through all of the channels available, and it will build up some metrics on the performance of the traffic on that channel. Therefore, the next time that something happens that causes the access point to have to move to a new channel, some sort of interference for example, then the access point knows which channels offer the potential for better throughput and will choose one of the channels that it's picked up on when it's scanned using channel fly. When channel fly is operating, it's still useful to know what other access points are out there, so background scanning will continue to perform. So it's not a question of channel fly or background scanning. When we decide to use channel fly for self-healing, we still perform background scanning, so it's not an either-or situation. There are plenty of resources out there that explain channel fly to a much greater depth. If this is something that you'd like to know more about, I recommend that you do check out some of the other videos that are dedicated to this. Moving on then, we see the next items on the list, and that's load balancing, which includes client load balancing and band balancing, and radar avoidance pre-scanning. Let's start then with a look at client load balancing. Client load balancing balances the client load across access points. It's disabled by default, it's enabled globally, and once it's enabled it can be disabled per WLAN. The way it works is that once a radio starts to become overloaded with clients, if there's spare capacity on a nearby access point, then the client will be denied a connection on the principal access point and instead will be forced to connect to a secondary access point. This may mean that it doesn't quite get as high data rates, but overall the network is more balanced and therefore will perform better. Next we have band balancing, and band balancing balances the client load across radios on the same access point. It's disabled by default. Once enabled it can be disabled per WLAN, and the way it works is by analysing the amount of connected devices. Now naturally devices will attempt to get the highest data rate possible, and in most cases this is in 5 GHz, so chipsets are designed to look for a connection in 5 GHz. The problem is that it means that most, if not all, of the devices that are connected will be on the 5 GHz radio. So band balancing pushes some of these devices down to 2.4 GHz. Once the threshold kicks in, new devices are spread between the 5 GHz and 2.4 GHz radio. With both client load balancing and band balancing, it's really recommended that you don't enable these unless you really have analysed your network and you're able to understand the results. The best thing is always to let the controller manage the radios and the connected devices. However, these options do exist, and if you're able to analyse your network operations at a fine level and understand how these changes will affect your network operations, this is something that you may look to utilise. The final option we're going to look at here is radar avoidance pre-scanning, which pre-scans DFS channels in 5 GHz and blocks any channels if radar is detected. This only applies to a certain number of outdoor access point models, and it's also tied to the country code because the country code determines the behaviour of the 5 GHz channels. Here's how it works. When the access point powers up, it chooses the first channel available and scans. If it doesn't detect any anomalies, then it'll list the channel as safe to use. The access point then moves to the next channel on the list and once again scans. And as it scans, the access point is looking for anything that has a signature that could be radar. Primarily this is military or aviation radar, but in fact the access point logs anything that could be potentially a radar signal, and it will mark the channel as out of use and it will log DFS block radar in the event logs. It then moves on to the next channel and again scans, and if everything's okay, we'll mark it as a channel that's available to use. The access point will then choose one of the channels that it knows to be okay to operate in and start to operate as normal. If for any reason now the access point has to move to a new channel, then it will select one of the channels that it knows is clear of radar. That brings us to the end of Configure Services Part 1. Join me in Part 2 when we look at the rest of the settings.